All right. So, greetings, scholars. Let's see. Hope everyone is doing well. Should be single page. All right. So, okay, not bad. We're doing pretty good with these starting on time. I kind of learning like best way to kind of do things. So I've officially done my first wave, right? So if anybody's running a little bit late, let me do one more. Let me check one more time. Because, yeah, let's see, we got a good amount. Get these gentlemen. Okay, I think I got all these students. Looks good. Okay, I'll let them in. Let me check the chat really quick. Bring it to my attention towards the end of class, and if it needs to be private, then we can, we can make a breakout room or whatever. I just bring it up towards the end of class. Ooh, okay. So we'll start here. All right. So let's see. So I don't think he's in there. Let me see. So it's no major announcements. The main thing is that as long as you're getting your attendance credit by making your way into my Zoom on our regular sessions, and you're just being in communication, then that's one main thing that I expect from you all. And then the other thing is that you're submitting your assignments on my math lab promptly, right? If you have questions or concerns about anything, feel free to unmute yourself to get my attention and we can talk about it, or feel free to type it in the chat. I am monitoring the chat. Matter of fact, let me pull that up here. I'll be right with you all. Let me see. Start. I don't want to claim space versus space. I need to disconnect the audio on one of these. Let me see. Disconnect the audio. Share my screen. Start the broadcast. All right. Roland Taylor. All right. So usually I do only 2 waves, but let me try to get these gentlemen. Just because it's kind of disruptive. Let's see. That one. Okay. I think I got him already. There he is. Okay. There's that one. Oh, okay. There he is. Okay. We're looking good. All right. I'll let these gentlemen in. All right. Actually, not there. Here. All right. So we're going to kind of let that be. That looks good. Okay. And I need to check one other thing. Where is it? Right here. Okay, we're good. Okay. All right, gentlemen. So let's see. Yeah, so just making sure that you're getting your attendance on a regular, like every time we meet, you're getting your attendance. And again, all it takes to get your attendance is to make your way into my Zoom. As long as you are able to join my Zoom and I don't say anything, then that means I've gotten your attendance, because basically, again, I take attendance as I let you all in. And then just be sure to be submitting your assignments via Pearson or MyMathLab promptly. If you have questions, hopefully you guys can hear me okay. If you have questions or concerns about anything, feel free to either unmute yourself or type in the chat. I am monitoring the chat, so that is there. Okay, and so let's kind of get into it. So our rhythm for the semester from here on out is essentially we have like each week we focus on one section. Like this week, I think we're focusing on two just because we're trying to get caught up. But each week is basically one section, and then every 4 weeks is an exam, right? So then every fourth week, we're focusing on an exam, right? So this week, we're continuing chapter 1 on graphs and functions, and today we're going to be focusing on section 1.2, lines, all right? So a few objectives here. We like to find the slope of a line, write the point slope form of the equation of a line, write the slope intercept form of the equation of a line, recognize the equations of horizontal and vertical lines, recognize the general form of the equation of a line, and find equations of parallel and perpendicular lines. Also, another piece of information, hopefully you all have found my YouTube and you've subscribed with your notifications turned on. Generally, what you see me doing in these type of presentations where I'm going through the lecture is you already have access to anything that I'm going to say, because that's what you see in my pre-recorded lectures is pretty much the same thing I would say in these live sessions. So you do have the ability to watch these at your leisure and actually get ahead. Also, all homework and quizzes are available right now for the entire semester. So you can actually get ahead and complete those assignments, and then that way you're only waiting on the exams. You just want to be careful about procrastinating and letting this stuff pile up, because you don't want to be in that boat of trying to play catch up with this. Okay, let me see. It's okay. Yeah, it's okay. Yeah, the main thing is that you've gotten your attendance credit, so just do the best you can. Again, this session is being recorded, so you can always pull it later if you need to. Let's see. I can't think of anything else. Okay, let's keep going. So we have some definitions. It says, let me see, since the graphs of first degree equations in two variables are straight lines, these equations are called linear equations. We measure the steepness of a line by a number called its slope. So if you think of straight lines, can anybody describe to me like where you might experience something being steep in your everyday life? Like what's something that either has a slope or that's something that has steepness in your everyday life? Like
a trash can.
A hill.
Okay, how is a trash can?
Like the inside of the trash can is steep. It has a slope.
Okay.
Or like because it's a cylinder and it kind of has like
it's kind of like
it's like diagonal. You know what I'm saying? Like
it is. They typically are tapered a little bit. I can get down with that. I don't think anybody's ever said that as an example, right? Some students from earlier, they like they said, well, like stairs, right? I was like, okay, yeah, that makes sense because it's like a slope, right? And so the more steep the stairs, the harder it is to climb. Then it becomes a ladder at one point. And I think a student did say a ladder. I think students were saying mountains, and it's kind of funny because my TV has a mountain screensaver on right now. But these are all things that have slopes, right? A hill. For MyMathLab, so there was a request for the course ID for MyMathLab. There is no course ID. The way we access MyMathLab is we go to Blackboard, and then I think it's item number 3 or 4. It's going to say assignments. And so if you go to Blackboard, you open up the main folder, and then item number 3 is going to say assignments. You open that up, and then the very first link is going to say MyMathLab all assignments. You click on that link, and then you follow the prompts. You are required to purchase full access right now. If you haven't already, I do encourage you to use the 14-day temporary trial, right? So as you're following the prompts for registration, one, be sure it's a good idea to register with your Morehouse credentials. And then 2, on the page where you're prompted for payment, towards the bottom, there's going to be a link that says get 14 days of temporary access. You can go ahead and use that link to gain access. It'll give you full access for 14 days. We already had at least 2 assignments due, so there is a late penalty for those assignments. for right now, I'm just gonna let that be, right? So you know, it's just a homework and a quiz, right? So 10% of 10% is like what? 1% of your overall grade. So that means the highest you can earn is a 99 in class, right? So it's a very small point deduction at this point. Again, the main thing is that we're getting started. And honestly, if we're at the end of the semester and you're like that close, I would just give you those points. All right. So I don't want you guys stressing about the late penalty for that assignment. The main thing is we're trying to get up to speed and get ready for exam 1 during week 4. Yeah, so that's the long and short there, right? Okay, so again, also whatever we don't finish together with this section, I do expect you to watch my pre-recorded lecture on my YouTube channel. Take notes as if you're in class and things of that nature. Let me see here. Doing agree. Let's say in class. It's okay. It's okay. It's okay. Yes. Remind me. Okay, so if today's your first day, just kind of remind me towards the end of class. And at least I do at least want to mark you as excused, but I think if you're just getting at it, it's not going to be an issue. We've only had really like one set of assignments really due, and again that late penalty is small, like is almost non-existent. The main thing is just go ahead and gain access and get started. As long as you get started, like basically our assignments are due on a weekly basis. I think like Sunday nights, right? So as long as you go ahead and get started, you're going to be fine. Get started and get the thing submitted. Don't stress about the penalty for that first set because it's really small. It's not anything. But I do want to make sure that in my roster that you've been marked as excused. So just kind of remind me towards the end of class, and I'll go and update that. Because that's kind of the long and short there. I'm not going to let attendance, as long as you're attending regularly, you're in high communication, and you're submitting your assignments, we're not going to let attendance be an issue for the most part. Okay. So let's see. So it says we have the rise is the change in the y coordinate between points, and the run is the corresponding change in the x coordinates, right? So essentially for slope is the rise over the run, or the change in y over the change in x. All right. So what we have here, 2 examples showcasing slope. Notice that for this first one, as we trace it left to right, the graph rises, it goes up. All right, so this is an example of something that we say that has positive slope, because as we trace it left to right, the graph goes up. But the second one, as we trace it left to right, the graph falls. So this is an example of something that has a negative slope. Okay, all right, so I feel like that's straightforward. So the slope of a non-vertical line that passes through the points P and Q is denoted by M and is defined by this. So the slope is the rise over the run, which is the change in y over the change in x, which is y2 minus y1 over x2 minus x1. The slope of a vertical line is undefined, right? So I think last time we mentioned, I do try to encourage you all to have a notebook, right? Part of the game of this experience of college algebra is basically organization and time management, right? Your ability to be neat and organized as much as possible, along with have proper time management. It's very easy to kind of like procrastinate and to get behind. Once you get behind, now you're playing a game of catch up, and that can be it can be difficult to get caught up. College algebra, the concepts are not difficult, but it is easy to get overwhelmed because it can be information overload, right? So I say that to say, if you have a homework notebook, there are 3 items in there that you want to be creating as we progress. One, it is a good idea to have a formula sheet, right? Where every time you come across a formula such as this, you update your formula sheet, right? And so that way, going forward, if you're using your notes for whatever, and then it was like, okay, well, I got my formulas here ready to go, right? You're not like constantly scrambling and going back and forth, right? So 1, in your notebook, you want to have a formula sheet. 2, you definitely want to have a copy of these lecture notes on some level. Either you're writing this by hand yourself, or you're like, printing this out. Or if you're like, for instance, I'm working on an iPad and I'm using Notability. So if I were the student, then I would try to pull a copy of the PDF and have it on file, right? You go through the notes and update them with whatever you see fit. And then last thing in your notebook that's recommended is that you have your homework section, right? So like for each, each section you have your header, like for instance, this is 1.2 lines. And then every homework question that you do within this section, you have a copy of the original question. You have all supporting work for each question. And then your final answer is in a box and it jumps off the page, right? The better you're able to kind of create your own manuscript like this, the better off you are, because that's how you learn it, right? If you borrow somebody's notes, that's like using the book. That doesn't really serve you. That's like kind of searching the web. You'll get a few questions here and there, but you won't know anything. And I know that right now we're not in a testing environment, but that doesn't mean that you're not going to be responsible for this in the testing environment. In other words, just don't be surprised if one day you find yourself in a testing environment where you're responsible for this stuff, right? And so I'm trying to encourage you all to kind of do these habits so that you're not wasting your time. That way, if you do find yourself in a testing environment, it could potentially be the final exam for this semester. That could happen, or it could be some other time that's critical, like a job interview or something like that. You don't want to get into those positions and then you waste your time, right? Also, as we move forward, if you need help, just ask. Between my office hours and class time, I think you guys started a group me. I think that's a great idea. Pearson pretty much explains how to do each question. And then the tutors, all right? So it's a good idea to try to connect with the tutors. The tutoring service is included in your tuition. You've already paid them. And if once that's going, they're essentially just sitting there waiting for you all to show up and ask questions. You can totally take this material, sit down with them and say, hey, can we work on this together? That's totally okay for me for right now. It's a 15-minute mark, so let me check Zoom, my waiting room one more time. The waiting room is looking good. You guys are awesome. Okay. And yeah, so the chat looks good. So I kind of been responding to questions there. And yeah, feel free again, if you have questions, either unmute yourself or submit it in the chat. Okay, so this is, again, we have the slope of a line. We have the formula for the slope of a line. Again, if you have a formula sheet, you definitely want to update it with this item here. Let's keep moving forward, okay? So in this example, we're asked to sketch the graph of the line that passes through these points and then find and interpret the slope of the line. Okay. So with this, I kind of want to do the following. All right, let's do like this. Hopefully you don't go too crazy. Let's see. Let's do this color. I guess I could do that. That might be a little bit faster and easier. Let's try that instead. Let's grab this. I want from there. 1, 2, 3. I want these guys. That looks good. That looks good. So let's copy and delete. And hopefully you allow me to paste. Come on. Allow the paste. Let's try that one more time. There we go. Nice. Okay. So in Zoom, you'll see these reactions, right? We're gonna let's let the applause hand, the clappy hands, we're gonna let that represent quadrant 1. We're gonna let the thumbs up, we're gonna let that represent quadrant 2. We're gonna let the heart represent quadrant 3. And we're gonna let the LOL emoji represent quadrant 4. All right, okay. So 1, 2, 3, 4, right? Okay. So real quick, inside of Zoom, right here, okay. Which quadrant is the point P in, right? If you think the point P is in quadrant 1, just in Zoom real quick, use the clappy hands, right? The applause hands. If you think it's in 2, use your thumb up. If you think it's in quadrant 3, we're gonna just use the heart emoji. I see one laughy face, one LOL. Okay, I can get down with that. All right. So point P, right? Okay. So let me see. Like if we were plotting the point P, all right, I'm seeing the LOS. I don't know why that always makes me laugh. It always makes me laugh. I don't know why. It's so silly. Okay. So we're starting at the origin, right? We go right one and down one. So I agree. That does put us in quadrant 4. Okay. So point P should be in quadrant 4. Similarly, what quadrant is point Q in? Again, if you feel like Q is in quadrant 1, you would do the clappy hands. If you feel like it's 2, you do the thumbs up. If you feel like it's 3, you do the hearts. I see a lot of clappy hands. All right, clappy hands is in quadrant 1. Let's see. So with Q, if we start at the origin, if we go right 3 and up 3, I can get down with that. We should be in quadrant 1, right? Cool. So we got some feedback, right? So it's not so passive. I like that. I am actually going to save this for later. Likey. Let me copy. All right, what am I doing? Let's go like this. I just want to kind of over to the side for now. Cool. So if we're working in quadrant 1 and quadrant 4, that's kind of like the right-hand side. So when I do my sketch, I'm just going to kind of focus on the right-hand side, right? And I just like that because it's quick. It's something that's a little bit interactive. You know, it typically makes me laugh because it just seems so absurd. Instead of creating a poll, just something that's quick. You know what I mean? Okay. So let's plot these points really quickly because we are asked to sketch the graph, okay? So let me see. I think if we go 4 in all directions, let's see, 1, 2, 3, 4. I'm doing the best I can to try to make these spacings uniform. You know, it's not like random spaces. I'm trying to get them to be spaced evenly. Our positive X is going in this direction. Our positive Y is going to this. Again, this is a rough sketch. So this isn't necessarily drawing the scale. I'm trying to be, I could introduce graph paper. I'm just trying to keep it light. Okay, so if we plot the point P, we said we go right 1 and down 1. So we're going to be right about here. I'll label it as the point P, which is 1, -1. And then the point Q, we go right 3 and up 3. Over 3 and up 3 puts us about here. I think I'm going to move that just a little bit. And actually, being a little bit OCD, let me copy and paste right here. All right, that's good enough. And then, so, you know, if we're going to create a line, we need at least 2 points, and then we just basically connect them with the straight edge, right? Again, if we're going to draw a line, a distinct line, we need at least 2 distinct points on the line, and then we just connect those points with a straight edge, right? So we're gonna let's do like this for right now. Oh, wait. Let me try one other thing. I want to see if I can do something quick. Undo. What if? No, I don't think that's working. Okay, that's okay. Let's go here. Right, and usually when we draw a line, it should. Now again, this isn't necessarily drawing the scale. If I want to be more accurate, I would use graph paper, and then that way everything would be spaced properly. It would connect properly because I'm not sure if that should connect at -3 or not. Again, so because we're not using graph paper, that's why it will be a little bit off. So, and let me do this if I can get it to work. Okay. That's good like that. Okay. So we get an image like this, right? Okay, this looks good. It might be, you know, I think that's decent. So then we're asked to find and interpret the slope, right? Let me do like this really quick. So like kind of graphing and stuff like this, I don't know why I like it. Because it's kind of like art, right? And it's taking these like, you know, mundane concepts and just bringing a little bit of life to it, right? Okay, so then the slope, right? So one of my mentors would say every time you use a formula, write it down. That constant repetition of writing the formula is how you ingrain it in your memory, right? So if we're using a slope formula, which is the rise over the run, that's going to be the change in y over the change in x. So our slope is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, this is our slope, all right? Another thing also that I like to do, whenever I'm given ordered pairs, personally, I like to just automatically label them, right? Like x1, y1, x2, y2, right? So we've labeled our components. We have an appropriate formula. So now we're ready to basically plug them into the formula, right? So the next recommendation is when we're doing our substitutions, first we want to replace each component with a blank set of parentheses. All right, we want to replace each component with a blank set of parentheses. So we're going to say y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? So then if we do our substitutions, y2 is 3, y1 is negative 1, x2 is 3, x1 is 1, all right? So the reason we did that was so that we can be cognizant or aware, keeping track of these signs, right? Without the parentheses, it's really easy to miss this. So the parentheses help us to realize like, oh, we have a double negative going on here, right? And double negative becomes positive. So just to be aware of that. All right. So that's a common error where students tend to miss that. Okay, if we keep going. So then 3 plus 1 is 4. 3 minus 1 is 2. So then the slope ultimately is 2. It's 2. Okay. All right. So again, anything that you see me writing here, let me check my chat. We got a lot going on in the chat. We said that there's a deduction on the homework. It's late. The best grade I can get on the assignment. No. Okay. The 99 was referring to your overall grade in the course, right? Because the homework counts for 10% of your overall grade. And I think the quizzes count for 10%. But then if there's a 10% late penalty, the highest you can earn on the late assignment is like 90%. So then we're talking about, the points lost is 10% of 10%. So that means, with that one assignment that's late, the highest you can earn is a 99. As long as you go ahead and get registered now and you get started and you submit your assignments going forward promptly, it's nominal. It's like it doesn't even exist. All right. The highest you're going to earn on a late assignment is 90%. All right. Any question that's submitted late is a 10% late penalty. And again, if we get to the end of the semester, if you guys are close, like, fraction of a point or something like that, if you're close, and I'm oftentimes I'm inclined to just like, okay, well, let me comp them those late penalties and see if that's enough to get them over, right? I'll do stuff like that, right? So I don't want you guys stressing about it too much. I like to keep those in place because I want you to have a little bit of just a little bit of anxiety so you can get moving. I don't want you to be too lax and get too comfortable. I want you to kind of get started and go ahead and do what you need to do. Right. Okay. So let's keep moving. Man, I really enjoy these classes, right? We only have maybe 15 minutes, a little over 15 minutes remaining, right? But again, whatever we don't finish together, I do expect you all to use my YouTube to go on there and, use my pre-recorded lectures. And here we have a typed version of what we just experienced together, right? Cool. I feel like the chat, I guess I'll leave it here for now. Okay, let's keep moving. All right. All right, so then is basically this is showcasing how to find the slope. Again, slope is the rise over the run, which is the change in y over the change in x. So y2 minus y1 over x2 minus x1. And long story short, they got the same slope that we got. Okay, let's keep moving. So in this example, we're asked to interpret, it says a slope of 2. Oh, sorry. Okay, so in the previous example, they also asked us to interpret what does a slope of 2 mean. A slope of 2 means that y changes by 2 units for every 1 unit increase in x. So every time x increases by 1 unit, y is increasing by 2 units. All right, so that's what a slope of 2 means. Okay, so that's interpreting the slope. A few main facts about slopes of lines. Scanning graphs from the left to right, lines with positive slopes rise and lines with negative slopes fall. The greater the absolute value of the slope, the steeper the line. The slope of a vertical line is undefined. The slope of a horizontal line is 0. Right? Okay, I feel like that's straightforward. If a line has slope m and passes through the point x1, y1, then the point slope form of the equation of the line is given by this. All right. So again, if you have your formula sheet, this is another formula that's a good idea to put on your formula sheet. Now for this one, to me, this one pretty much looks like the slope formula, right? I just want to do a showcase real quick to show you how you can, through some manipulation, minimal manipulation, you can generate this formula from the slope formula, right? So if we start with the slope formula, y2 minus y1 over x2 minus x1. Again, this is our slope formula. We can start by doing algebra and multiplying both sides by the denominator, right? So if we multiply both sides by the denominator, right? A number divided by itself cancels, right? And then I guess I'll go ahead and write it like this. So then now at this point, we have x2 minus x1 times m equals y2 minus y1. If the left equals the right, you can actually reverse the order and you can say the right equals the left, right? So then if we just flip it, we can say y2 minus y1 equals m times x2 minus x1, okay? And then lastly, if we just drop the 2's, then that gives us our point slope formula, right? So long story short, if we start with a slope formula, multiply both sides by the denominators and drop the 2, then we get our point slope formula, right? So the slope formula, I like to call that a twofer because I get 2 for 1, right? You can either just commit the point slope formula to memory, or be able to do this simple algebra, So that's the long and short there. Now, again, I know it's a little bit lax right now because we're not in a testing environment, but I do want to kind of warn you or give you a heads up. There is a possibility that our final exam could potentially be in person. Like that could happen. I know that happened in the spring, so I don't want you to be too lax, and I don't want you to be blindsided by something like that. In this example, we're asked to find the point slope form of the equation of the line passing through this point with the slope m, and then we're asked to solve for y. Okay, so point slope form, again, every time we use a formula, it's a good idea to write it down. So point slope is y minus y1 equals m times x minus x1, right? Also, we're given 1 point, so this is going to be our x1, y1. Okay, and we have our slope here. So then if we plug those components into our formula, we're going to have y minus, our y1 is -2. Notice my use of parentheses. 3 times x minus x1 is 1. Okay. And then we're asked to solve for y. So notice we have a double negative here that becomes positive. Okay. So then if we have y plus 2, we can isolate the y by doing the inverse operation. The inverse operation of plus 2 is going to be -2. So we're going to subtract 2 from both sides. All right. And I'll just put it here, I guess, for right now. Can anybody tell me what is this technique called with these arrows coming from the 3? What do you call it? What is that called? It begins with a D. What technique? Yeah, we're distributing, right? We have multiplication over essentially addition. Keep in mind that subtraction is just another form of addition. So then we're distributing that 3. So we're saying 3 times x plus 3 times the -1 minus 2, right? A number plus its opposite, these guys add to 0. So we're keeping our equal sign lined up. On the left-hand side, we successfully isolated our y. On the right-hand side, after distributing, we're going to have 3x minus 3 minus 2. And then we combine like terms. Ultimately, we get y equals 3x minus 5. Okay. So with this example, we were given a point and a slope. Generally speaking, we use the point slope formula when we're given a point and a slope. You don't necessarily have to start there. I'll show you an alternative momentarily. Again, if we don't, we got just under 10 minutes remaining. If we don't make it during the live, I would encourage you, it is a good idea to finish whatever we don't do together. Finish it in my pre-recorded lectures, okay? So we get this. Let's keep moving forward. Let's see. I think we satisfied all the conditions. And this is just a type version of what we just experienced. So in this example, we're actually, I think for the sake of time, I'm going to leave this as an exercise. Yeah, that's fine. I'm going to leave this one as an exercise for you all, just in the interest of time. Okay. Okay. So in this example, we're asked to find the point slope form of the equation in line with a slope m and a y-intercept of b. Okay. If the y-intercept is b, so that ordered pair, what's the ordered pair, right? If the y-intercept is b, can anybody tell me what's the ordered pair? What's our x comma y for the y-intercept? This one's a little bit different. So if the y-intercept is b, the ordered pair is going to be 0 comma b. Okay. And then our slope is just m. Let me clean it up a little bit. And again, this is, and so the formula that we're going to be using is the point slope because we're given a point and a slope. So that's going to be our y minus y1 equals m times x minus x1, okay? And again, this is our x1, y1, okay? So with this information, if we plug all this in, we're going to have y minus b equals m times x minus 0. So anything minus 0 is itself, okay? And if we're going to solve for y, if we're going to isolate the y, we use the inverse operation. So the inverse of minus b is going to be plus b. So we're going to add b to both sides. I just put it here. And that minus 0 essentially goes away. And a number plus its opposite, these guys add to 0. So if I bring down my equal sign on the left, the only thing that's left is y. On the right, we're going to have mx plus b. Okay. So this actually is another one of our formulas, right? So whenever we're working with lines, there are essentially 3 formulas that you want to have like on deck ready to go, right? We introduced today with the slope formula. We talked about the point slope form, and then lastly, this is what's called the slope intercept form. This is your classic y equals mx plus b. All right, so you see here's a type version of what we just experienced. So this is called the slope intercept form of the equation in line with the slope m and a y-intercept b is given by this. All right, so real quick, let me list out those 3 formulas. So again, whenever we're working with lines, the 3 formulas you want to have ready to go. The first one is the slope formula. That's your y2 minus y1 over x2 minus x1. Again, this is our slope. Okay. Next that you want to have ready to go is the point slope formula. Point slope formula. That's going to be our y minus y1 equals m times x minus x1. And then lastly, what you want to have ready to go is this guy, which is the slope intercept formula. I'm just going to abbreviate it like that. And that's the classic y equals mx plus b. Okay. So these are 3 formulas you want to have ready to go whenever you're working with a line. Okay. Okay. So here we're asked to graph the line whose equation is given by this. Okay. So notice this equation is in the slope-intercept form, which is in our y equals mx plus b. Our our slope is 2/3. Our y-intercept is 2. Right. So when a line takes on the form y equals mx plus b, to me that's the easiest way to graph. Right. I think earlier we said in order to graph a line, we need 2 distinct points. Can anybody describe to me what's our first point from this y equals mx plus b? Where do we start with y equals mx plus b?
Start from 2, the y-intercept.
Yeah, the y-intercept is 2. So we will go to the y-axis and put a dot on 2. And then basically the slope tells us how to get to the second point, right? So if the slope is the rise over the run, if we're on the y-axis, we start at 2, then we go up 2 and right 3. That's going to be our second point. We connect those 2 points with the straight edge, okay? So it looks like we're going to be working in quadrant 1. Again, I'm just going to do a rough sketch. So we'll focus on quadrant 1. So our positive y is in this direction. Okay. Positive x will go in this direction. Okay. We need to go to about 5 or 6 and over to about 4 or 5. Let me see. So let me see. 1, 2, 3, 4, 5, 6. Idealistically, you want to use graph paper here. If you do draw it by hand or rough sketch, try to be uniform, like with the spacing. That'll help. If the spacing is like not uniform, then it just goes kind of sideways. I'm gonna reduce this down, so I don't need that to go. I don't need that much. But the best thing for something like this is just use graph paper. Okay, so to plot this guy, this is going to probably be it for us for today. We're essentially out of time. Our y-intercept is 2, so that's going to be this guy here, right? Our second point, we go up 2 and right 3. Let me do like this. Copy and paste. Okay. So for the second point, we go up 2 and right 3. 1, 2, 3. Right about there. And then we basically connect this with the straight edge. Once we have 2 distinct points, connect it with the straight edge. Like that. And the line that we draw, we should extend it across the entire, our entire graph. Okay, about like that. Okay. And that's how. So again, when a line is in the form of a slope-intercept form, which is y equals mx plus b, to me that's the easiest way to graph. It's basically giving you instructions, right? It's saying that go to the y-axis, start at 2 in this case, and then if the slope is 2/3, to get to the second point, we go up 2 and right 3 and plot the point. And then once we get 2 distinct points on our graph, we connect them with the straight edge. And here's a typed version of what we just experienced. Okay. I think that we are out of time. So you definitely want to go through the remainder of the lecture notes because there are some important concepts there. We're just out of time. We don't have a lot of time together. You definitely want to use my pre-recorded lectures. Let me make a copy of this available for you all. So just want to make sure I'm in the right folder. 2023 traditional College Algebra 1 notes updated daily. That looks good. Okay, that's fine. So when this bar finishes loading, you'll get a copy of anything that you saw me writing. Are there any burning questions that anybody has? I know that there's one student that wants to do a breakout room. Are there any other burning questions? Going once, going twice. Forever hold your piece of rice. Okay. So if there aren't any burning questions, we're going to go ahead. Go ahead. Let me check the chat. Yes.
So on the bookstore, it said that we need like a book for this class. I'm assuming Pearson replaces that.
Yeah. Yes.
Okay. I was just asking to make sure.
Yeah, we're gonna be using we're gonna be using My Math Lab, right? So there's a couple of ways to gain access. My recommendation, you go to Blackboard, open up the main folder, and
Do like
then
go through Pearson.
yeah,
I did.
you could get it directly from the site, but on the page where you're prompted for payment, get the temporary access. I need to follow up with my colleagues to see if they were able to get a price reduction. So that's the only reason I'm. Go ahead.
I was just asking because, like, when I was in a bookstore trying to look for some books, like it said, like for the math class, there's 3 different books. I just wanted to see to make sure.
Yeah, just My Math Lab. Now, if you have, like, I know sometimes students have to use a book voucher. If you have to use a book voucher, then they should have where you can purchase just the My Math Lab access code with your book voucher. That's all you need. Is you just need a My Math Lab access code, right?
Yes,
Otherwise, if you can get it directly from Pearson, through the link in Blackboard, that would be my recommendation. That way, you're getting access to the right thing.
All right, thank you.
Mm-hmm. Any other burning questions?
Wait, Professor Phifer, I already bought a book. So should I like return it for like
more than well? If it comes with an unused My Math Lab access code, then you're okay.
I don't think.
Let me see. So yeah, you probably would have to. Yeah, you would want to try to get a refund because our main way that we're going to be doing our homework quizzes and exams is through My Math Lab. So like,
yeah. Wait a minute. It says My Math Lab Student Access Kit.
Did you buy the book brand new?
Yeah.
Yeah, it might be in there. Like I would say, just go to like the front cover or the back cover. There might be an access code in there that you can use, and that'll give you full access.
Oh, okay. All right. I see.
Yep.
All right.
These are good questions. Any other questions? Going once, going twice. Forever hold your P's and rice. Okay. So again, if there aren't any other burning questions, we're going to go ahead and end the session here. I think you guys know what you need to do. So yeah, we'll end the session, and from one beautiful mind to another, have a great weekend, guys. I'll see you Monday, same time, same place. Okay, take care. Peace.
All right, see you.
Yep. I'm going to stop the live stream, and who's the student? Let me stop the live stream really quickly.
Yeah. Wait, can you hear me?
Yeah, I can hear you. Just give me
okay.
give me just a moment.
Yeah.
Right here.